So first is about token analyzer plus the stop filter. So while reading a term, basically we have two things to do. The first one is word stemming. Word stemming means to find the root form of a word, of an English word. So we process a word so that only its stem or root form is left. For example, when we consider the word process, we have all those forms like process, processing, processes, and processed. And certainly we're not going to maintain posting lists for every one of them, but we only maintain one posting list for this root form of process. For most of the words, as simple as process, it's simple. We just recognize ing, es, ed, and just cut them. And that's the simple cases. Some other complicated case like say, right? We have says, said, and saying. But fortunately, you don't have to do this by yourselves. You can certainly find all kinds of tools from the internet and from some open source. Okay. The second thing is stop words. We're supposed to build a stop filter. A stop word is something that is so common that almost every document contains it, or say contains them, such as the word a, the, it. So it's useless to index them, because if we do, you can imagine how long their posting list will be. It will contain almost all the documents, so that's pointless. And they are called stop words. And it doesn't mean that they don't have their posting lists at all. They do have. For example, you can try to search for the word a and see what you can get. We can still get something, right? For example, an explanation of what a is. And if you search for it, you will probably get something that relates to IT, right? So it means that we do keep posting lists of these stop words. But before we do anything, the first thing to do is to eliminate them from the original documents so that those meaningless terms will not be processed. That's called stop filter. Okay, and that's about token analyzer. And next, it will be vocabulary scanner and inserter. So while accessing a term, we have many different tools that we can use, right? For example, in solution 1 is just to use search trees, but not AVL tree, not red-black tree, because comparing to B trees, they're not so efficient. Some say that red-black tree is a little bit faster than AVL tree in the sense that if there are many insertions and deletions, usually a red-black tree runs like from 10 to 20% faster than AVL tree. But that's actually when the size of the data set is not so big, 10% is no big deal. But if the size of the data set is really big, none of them works. A better choice would be the B trees, right? And this one, some pronounce it as trees or some like tries, is a tool to process English words. But basically they are all search trees. So one solution is we just implement a search tree for the quick accessing of a term. And solution 2 is hashing. Ideally, if we can carefully design a very good hash function, ideally we can access any term in a constant time, right? Although that ideal situation is usually hard to achieve. So here comes your next discussion question. What are the pros and cons, the advantages and disadvantages of using hashing comparing to using search trees? Now, think about it. Okay, now I assume that you have done your comparisons. Well, basically there are 2 points. The advantage is that if we're only searching for one word, hashing might be much faster than the search tree. However, if we use hashing, different words will be hashed into separated positions. So if the requirement is scanning in sequential order, that may not be possible. In other words, range searches are expensive. So think about this. When you're looking for one word and you made some mistake, there's a misspelling of the word. Will the search engine simply return to you nothing? Not really, right? Usually, a search engine will return to you something that even though you have made a mistake in the spelling, it will return to you the results that corresponds to the correct word with, well, probably some sentence like, are you actually looking for this? So how can they do that? If we use hashing, different words will be hashed into different positions, and that different positions might be quite far away. If we use search trees, for example, if we're talking about English, if we use trees to store those dictionaries, it's going to be really easy to look for not just one word, but a range of similar words. Okay, so much about the vocabulary scanner and inserter. And the last topic is on the memory management. If we don't have enough memory, what do we do? So this is the previous pseudocode for generating the index, right? If we're out of memory, so we're reading documents one by one and we're processing terms one by one, but at some point we're out of memory. And what do we do? And here is the solution. Okay, we initiate the block counter to be 0 first. If we're out of memory at this point, then we should write this block of index to the hard disk. Okay, and increment the block counter and free this piece of memory and continue. And while we're done with all the processing, we're supposed to merge all the blocks into the inverted index, block by block, okay, one by one into the final inverted index. So each block contains a subset of the posting lists, right? And we're supposed to merge those posting lists into the final posting list. So in order to make this step fast, we better keep all the block index sorted. Alright, I hope that you have obtained some basic idea of the inverted file index. And then we're gonna go through several topics that are mostly concerned by the researchers.